Imagine for a moment you could create a perfect digital twin of yourself. Or maybe even 1,000 perfect digital twins of real people.
Okay.
Each one able to accurately predict their thoughts, their actions. What could we learn? What kinds of, surprising insights might we unlock with that kind of human laboratory?
That is a really fascinating thought experiment. The potential there, it feels, well, immense.
It does. And that's exactly what we're diving deep into today. We're looking at some truly groundbreaking research. It's from Stanford University and Google DeepMind.
Right.
They're calling it generative agent simulations of 1,000 people.
Yeah, and our mission for this deep dive is really to unpack how they built these digital agents. How accurately did they actually manage to replicate real human behavior?
And what does it all mean?
Exactly. What are the maybe surprising insights this offers for understanding individuals and maybe even society as a whole? We'll try to break it down without getting, bogged down in all the jargon.
Think of this as your shortcut, your direct route to understanding what's happening at the cutting edge of AI and human behavior research.
Mm-hmm.
This deep dive is based on a really detailed research paper that goes into how they created and, importantly, evaluated these generative agents. So let's start right there. How do you even begin to build a digital human that's supposed to be that accurate?
Yeah, that's the fundamental question, isn't it? The big picture goal here, the researchers' goal, was to develop what they call general-purpose computational agents.
Okay.
Agents that can replicate human behavior across lots of different situations. They're essentially trying to build a whole new kind of laboratory for researchers.
A lab for human behavior. That opens up so many possibilities.
Precisely. It allows researchers to rigorously test a really broad set of interventions, theories, without needing to actually involve, thousands of real people every single time they have a question.
Right.
Imagine being able to simulate how a diverse group might respond to, say, a new public health policy.
Or a new product, maybe.
Or a new product launch, exactly. Or even how they'd react to, major societal shocks or changes.
So, okay, instead of rolling out some huge nationwide initiative and just kind of crossing your fingers.
Right.
You could test it on these 1,000 digital twins first. That seems incredibly powerful, especially for, piloting interventions, understanding social structures.
It really is. And it's a big step beyond the traditional agent models people used before.
How so? What was wrong with the old way?
Well, historically, those models relied on behaviors that were manually specified, pre-programmed, really.
Okay. Rigid.
Very rigid, which often restricted the agents to really narrow contexts and, let's be honest, often oversimplified how complex humans actually are.
But now with large language models, LLMs, that's changing things. You're saying there's a new opportunity to go much broader.
Exactly. LLMs, because they have this, vast understanding of human language, patterns of thought, they offer a real chance to build an architecture that can simulate behavior across many contexts. Much more general purpose, much more adaptable.
Okay, now this is where I found it particularly interesting. The core of this, the innovation, seems to be using these really in-depth qualitative interviews. Tell us about that.
It's quite ingenious, actually. The core method was creating over 1,000 of these generative agents by simulating real individuals. And the basis for that simulation was a 2-hour qualitative interview with each person.
A 2-hour conversation for every single digital twin. That's a lot of data.
It is a huge amount. They recruited 1,052 real people for these interviews, and it wasn't just any random sample.
No,
it was a carefully selected U.S. sample. Stratified is the technical term,
yeah.
Meaning they deliberately chose participants to mirror the diversity of the U.S. population across key things like age, gender, race, region, education level, even political ideology.
So the goal was for these digital agents to really represent the kind of the spectrum of the real world.
That was the aim, yeah, to make the simulation meaningful.
And who did the interviews? Was it like a team of researchers talking to all these people?
Well, this is another really crucial and frankly fascinating detail. It wasn't humans doing the interviewing.
It wasn't?
No. An AI interviewer actually conducted these interviews voice to voice.
An AI? Talking to people for 2 hours?
Yep, and it produced these lengthy transcripts, on average almost 6,500 words per participant.
Okay, hold on. An AI interviewer? How did it even know what questions to ask or how to, follow up naturally?
So it used an existing, pretty broad sociological interview protocol. It's called the American Voices Project. That gave it a solid base.
Right.
But the clever part was that the AI interviewer could also dynamically generate tailored follow-up questions
Tailored. How?
based on what the person was actually saying in the moment, much like a skilled human interviewer would do, to probe deeper into a specific topic or response.
Okay, that's pretty sophisticated. So you get these massive, detailed transcripts from AI interviews. How does that raw text become the agent's brain, so to speak?
Good question. So when an agent needed to, say, answer a survey question or make a decision in an experiment,
Yeah.
the entire interview transcript for that specific person was injected into the LLM's prompt.
The whole 2 hours worth of text.
The whole thing. It essentially told the model, okay, based on everything this person said in this interview, imitate them.
Wow. And wasn't there something else like an expert reflection module? That sounds like adding another layer on top.
It is, and it's quite a brilliant layer, I think. This module involved the LLM taking on the personas of different kinds of domain experts,
Like who?
like a psychologist, a behavioral economist, a political scientist, and a demographer.
Okay.
And each of these expert personas would then read the interview transcript and synthesize abstract insights from it. Up to 20 observations per expert.
Can you give an example? Like, what would the digital psychologist pick up on?
Sure. So the psychologist persona might look at the transcript and note, this individual shows a strong preference for independence based on their responses about work and family. While the political scientist might infer something like, despite identifying strongly with one party, their views on specific issues suggest a more blended or nuanced ideology.
I see. And the demographer.
The demographer might focus on things like income, job type, geographic location, and how those factors relate to broader socioeconomic trends discussed in the interview.
Got it. And when it came to actually making predictions like answering a survey, they used a chain of thought strategy. What does that involve?
Yeah, it's like making the AI show its work, basically. It was a 4-step process for each prediction.
Okay, step one.
Step 1, option interpretation. The AI describes the kind of person who might choose each available answer option.
Right.
Step 2, option choice. It reasons about why this specific participant, based on their interview, might lean towards one particular option.
Mm-hmm.
Step 3, reasoning. This is where it explicitly explains which option it thinks best predicts the response, linking it back to the interview data and those expert reflections.
And
Finally, step 4. The actual response, just selecting the final answer. This whole layered approach helps the AI make predictions that feel more human, more nuanced, like someone actually thinking through their options.
that is an incredibly thorough way to build these digital people. But the million-dollar question, right? How do you know if it actually worked? How do they measure accuracy? What was the gold standard?
This is where their methodology really shines, I think. They were super rigorous about measuring accuracy. They compared the agent's predictions directly against the actual responses of the human participants.
Oh.
So first, the human participants completed a whole battery of standard social science surveys and experiments. Things like the General Social Survey, or GSS.
Yep, familiar with that.
The Big Five personality test, various economic games where they make decisions about resources.
Okay, so that sounds like a pretty standard way to get baseline data on the humans.
It is. But here's the really crucial twist. 2 weeks later, the exact same human participants retook the exact same surveys and experiments.
The same ones. Why?
To establish their own consistency over time. Because, let's face it, people aren't perfectly consistent. Our attitudes, even our behaviors, can shift slightly from day to day, week to week. Moods change, things happen.
Okay, so they weren't just comparing the AI to one snapshot of the human. They were comparing the AI's accuracy to how consistent the person was with themselves over 2 weeks.
Precisely. That's a much tougher, but also much fairer benchmark, right?
Exactly.
And this led them to define this key concept, normalized accuracy.
Okay, explain that.
They basically took the agent's raw prediction accuracy and divided it by the individual human's own retest reliability, their self-consistency score.
So a normalized accuracy of 1.0 would mean?
It would mean the generative agent is just as accurate at predicting that person's responses as the person is at replicating their own responses 2 weeks later.
Wow. That's an incredibly high bar to clear.
It absolutely is.
Okay, so we've got the how they built them, how they measured them. Now let's get to the what. What could these digital humans actually do? Let's start with predicting attitudes and behaviors on those standard measures.
Right. So they evaluated the agents using those canonical social science tools. the General Social Survey Core Module, the Big Five Personality Inventory, the BFI 44 version, and 5 well-known behavioral economic games.
And crucially, they compared these fancy interview-based agents against some simpler baselines, didn't they, to see if the interview effort was really worth it.
Exactly. They needed to isolate the value added by those super in-depth interviews. So the baselines were, 1, agents given only basic demographic info, age, gender, race, etc.
Okay.
And 2, agents given a short persona description that the participants wrote about themselves.
Got it. So, first up, the General Social Survey covers a lot of ground on social attitudes. How did the interview agents do there?
On the GSS, the interview-based agents hit an 85% normalized accuracy.
85%.
Yeah.
So 85% as accurate as the person was with themselves 2 weeks later? That sounds pretty good.
It's really quite high, and here's the key comparison. They significantly outperformed the baselines.
How significantly?
The demographic-only agents got 71% normalized accuracy. The self-written persona agents got 70%.
Okay, so a jump of 14, 15 points, that's substantial.
It really is. It clearly shows the power of that rich, qualitative interview data for predicting attitudes.
What about personality? The big 5 traits like openness, conscientiousness.
Similar story there. For the Big Five, the interview-based agents achieved a 0.80 normalized correlation.
Correlation, right. So closer to 1.0 means a stronger relationship. 0.80 is pretty strong.
Very strong in this context. And again, significantly better than the baselines. Demographic agents were at 0.55 correlation, and persona agents were at 0.75.
So again, the interview provides a real edge for capturing personality. Okay, so attitudes and personality check.
Oh.
What about those behavioral economic games? Things like, the ultimatum game, dictator game, decisions
Yeah.
about fairness, trust, money.
Right. On those games, the generative agents got a 0.66 normalized correlation.
Still sounds decent, but maybe not quite as high as personality.
Correct. But here's the really interesting finding for the games. There was no significant difference in performance between the interview-based agents and the baseline agents.
Wait, really? So the interviews didn't help for the economic games. That seems counterintuitive. Why not?
Well, the takeaway seems to be this. Those deep qualitative interviews are particularly valuable for tasks that tap into really personal, nuanced stuff, attitudes, beliefs, personality traits.
Things that make you uniquely you.
Exactly. But for highly structured decision contexts like these economic games, which might rely more on, say, immediate calculation or maybe simpler, more universal behavioral rules,
Yeah.
the extra depth from the interview didn't add much predictive power beyond what you could get from just knowing demographics or a short self-description.
Huh. Okay, so the interviews are magic, but maybe selectively magic. They work best for capturing that deeper sense of self.
That seems to be the implication. It highlights where the real value of that intensive interview process lies.
Okay, predicting survey answers, personalities, some behaviors. But the next level up, surely, is predicting how people react in actual experiments, right? Where there are manipulations, treatment effects. That feels way more complex.
It absolutely is. And this, for me, is maybe the most jaw-dropping result in the whole paper.
Oh, lay it on us.
So the agents essentially participated in 5 well-established social science experiments, just like the human participants did. These experiments were designed to test specific causal effects.
Like what kind of effects?
Things like how much perceived intent matters when assigning blame, or how experiencing unfairness affects your emotional responses in a group setting, or how having power influences trust, or even how dehumanizing language might increase willingness to harm. Classic stuff.
Okay, complex social psychology. And the results.
Yeah.
Did the digital twins act like the humans in these scenarios?
Get this. The human participants in the study successfully replicated the known findings from 4 out of the 5 original experiments. They failed to replicate the 5th one.
Okay, that happens in science. Replication isn't always perfect.
Right. But here's the kicker. The generative agents replicated the findings from the exact same 4 studies as the humans did, and they also failed to replicate the 5th one, just like the humans.
Whoa, hang on. So they didn't just get the effects right, they also got the failures right. They mirrored the human pattern perfectly.
Perfectly. It's, almost unsettlingly accurate.
What does that even imply?
Well, for one, the correlation between the size of the experimental effects found in humans and the effects found in the agents was incredibly incredibly high. A correlation coefficient of R equals 0.98.
Practically perfect correlation.
Almost. And the significance is huge. It shows these agents aren't just predicting individual survey answers. They seem capable of reliably predicting population-level responses to complex interventions and manipulations.
That just opens up entirely new ways to do social science, to test policies.
Exactly, without having to run massive, expensive human trials for every single variation you want to test.
Wow. Okay. So we've seen these incredible capabilities. Let's shift to the so what. What are the bigger implications here, and how are the researchers thinking about the real-world impact, maybe the potential downsides?
Yeah, that's critical. One really important issue they tackled head-on is bias in AI. The concern that AI systems sometimes don't perform as well for, or maybe even misrepresent, people from underrepresented groups.
Right, a major concern with AI development.
Definitely. So they used a specific metric to look at this called the demographic parity difference, or DPD.
Okay, what's that measure?
It basically measures the performance gap, the disparity between the demographic group the agent performed best for and the group it performed worst for on a given task. A bigger DPD means more bias or inequality in performance.
And what did they find? Did the interview agents help with bias compared to, say, just using demographics?
Yes. This is a key finding. The interview-based agents consistently reduce these performance disparities, the DPD, across all the tasks. The GSS, the Big Five, the economic games.
Consistently reduce bias. How much?
Well, for example, looking at political ideology prediction on the GSS, the DPD dropped pretty significantly. For the demographic-based agents, it was 12.35%. But for the interview-based agents, it fell to 7.85%.
That's a noticeable improvement.
It is. Interestingly, though, they noted that gender-based DPD was already quite low across all the agent types and didn't change much.
So the takeaway is that getting that really deep individual understanding from an interview helps the AI build a fairer, more equitable model, reducing reliance on potentially stereotypical demographic shortcuts.
That seems to be exactly right. The richness of the interview data allows the AI to form a more complete, less biased picture of the individual.
Which translates to fairer and more accurate predictions for everyone. That's a really positive finding.
It is.
Why exactly are these interviews so powerful, though? Did they dig any deeper to kind of pinpoint what made them so effective? Was it just the length?
They did run some extra analyses to explore that. For instance, they tried building agents using only the data from the surveys and experiments the humans took.
Right, the kind of quantitative data traditionally collected.
Exactly. And those agents actually underperformed compared to the interview-based agents.
Okay, so interviews capture something surveys miss.
Strongly suggest that, yes, interviews grab richer, more comprehensive information.
But what if you didn't use the whole 2-hour interview? Maybe just a part of it.
They tested that too, even when they randomly chopped out 80% of the interview transcript.
80%.
Yeah, leaving only 20%. Even those heavily truncated interview agents still outperformed the agents built only on survey and experiment data.
Wow, so interviews are really information dense, efficient.
Incredibly efficient at capturing valuable insights, it seems. It's not just about the sheer volume, it's the quality and depth of what's discussed.
Okay, but what is it about the interview? Is it the way people talk, the nuances, the pauses, the linguistic cues? Or is it just the factual information conveyed?
Another great question they tried to answer. They created what they called interview summary agents.
Meaning?
Scripts and convert them into just bullet-pointed factual summaries, stripping out most of the natural language, the conversational flow, the linguistic style.
Okay, just the facts. How did those do?
Remarkably well, actually. Those summary-based agents still achieved 0.83 normalized accuracy on the GSS, almost as good as the full transcript agents.
So it suggests that while the language processing is important, a huge part of the benefit comes from the knowledge itself captured in the interview, not necessarily just the exact way it was said.
That seems to be a key insight. The substance of the conversation, the facts, the experiences, the opinions shared, that knowledge is incredibly powerful for prediction.
This whole area, it obviously has just immense potential, right? Simulating policies, interventions, training AI, but, with great power.
Comes great responsibility. Absolutely, those ethical considerations are paramount.
What are the main risks they identify?
Well, the potential for social science and machine learning is clear, like we've discussed, but the risks are serious too. Obvious things like privacy concerns for the participants whose interviews form the basis of these agents.
Right.
The potential for misuse. Imagine someone using these agents for manipulation or targeted misinformation, or even the risk of falsely attributing statements or beliefs generated by the agent back to the real individual.
Yeah, that's scary.
Yeah.
So how are they proposing to manage this? How do you balance the huge potential benefits with these very real risks?
Stanford, where much of this research originated, has put a lot of thought into this. They've proposed a two-pronged access system for the agent bank.
Okay, prong one.
Prong 1 is relatively open access, but only to aggregated responses from the agents on fixed tasks, like the overall results on the GSS or the Big Five.
So population-level insights, but no individual agent data.
Exactly. That allows broad research use while protecting individual privacy.
And prong two, for more detailed stuff.
That's much more restricted access. This would allow researchers to query individual agents, maybe on new, open-ended tasks for deeper custom research.
But with safeguards.
Absolutely. This restricted access would involve a rigorous ethical review process, significant safeguards, usage audits to see how the data is being used. They've also built in participant withdrawal options. Participants can ask for their data to be removed for up to 25 years. And there are strict non-commercial use agreements.
So they're trying to model it on how other sensitive data, like genomic data banks or responsible AI models, are managed.
That seems to be the approach, balancing enablement with strong ethical guardrails.
Okay, so wrapping this up, the central finding here is just pretty remarkable, isn't it? That these generative agents, especially when they're fueled by these rich qualitative interviews, they can simulate human behavior and attitudes with, frankly, astounding accuracy. Sometimes as accurate as people are with themselves over time.
It really underscores the power of that in-depth interview method, not just for accuracy, but for capturing nuanced identity and, importantly, even reducing bias compared to simpler approaches.
It feels like a foundational piece of work.
I think it is. It provides a potential blueprint for developing really powerful new tools. Tools to investigate individual behavior, collective behavior, at a scale we just haven't been able to before.
Which brings us right back to that opening idea and maybe leaves us with a provocative thought for you, the listener, to mull over.
Yeah.
If AI can simulate our responses, our attitudes, our behaviors, almost as accurately as we replicate them ourselves, what does that really tell us about the predictability of human nature? And maybe more practically, how might these kinds of digital laboratories, these simulations of thousands of people, fundamentally change how we approach understanding the immense complexities of human society?
That's definitely something to think about.
Something to mull over as you go about your day.